So now we are going through bitwise operator. Okay. So basically, the operator will be used to perform the operation on individual bits of the value are known as bitwise operator. Okay. So first we'll start with bitwise AND. Okay. So the bitwise AND, you see this is the symbol of bitwise AND. Okay. So what it will do? I have in just now in example you have see that, right? What I did, I have taken int a equal to 6, int b equal to 3. Okay. And now what I'm doing? I'm just performing AND operator. This is not plus, this is AND. Okay. So what I'm doing? A and B. Okay. In logical AND, what happened? Like we used to take a boolean as a operand, and then if if both is true, then we used to return true. Okay. But bitwise AND is different. Okay. In bitwise AND, if you see here, first what you have to do, let assume I have taken int a equal to 6. So first we have to convert it to binary, because as per definition it will perform operation on bit. So I have see here, I have written 0 1 1 0 1 1 0 0. So this is called bitwise AND. So in logical AND also what happens, when both are true, then it's true. Means if both are 1, then it's 1. If any one of 0, then result will be 0. So that is the basic logic of bitwise operator. So I have converted 6 into 0 1 1 0, which is their binary representation, and then 3 0 0 1 1, which is their respective binary representation. Then I am performing AND operation. So 0 1, 0 means false, 1 means true. So 1 false, 1 true means false, right? Okay. Both are true, 1 and 1. Both are true, then true. 1 and 0. True and false, 0. 0 represent here in beat level, 0 basically false and 1 basically true. Now 0 0. So 0 0 is become 0. Okay. So now we got this 0 0 1 0. When you convert it to decimal, you will get 2. Okay. Okay, as I said, when 0 and 0 become 0, 1 and 1 become 1, 1 and 0 become 0, and 0 and 0 become 0. So you always have to remember this. So any number they have given, let's assume they have given int a equal to 10, int b equal to 12, and now you have to perform a and b. So first you just convert 10 to respective binary, then 12 to respective binary, then you will perform AND operation. And while performing AND operation, you just check their respective integer bit. If respective integer bit, binary bits are 1 1, then 1, 0 1, then 0. In the case of bitwise AND. Clear? Clear everyone, or any doubt?
Clear हुआ.
Mm-hmm.
Yeah, it's clear. Yeah.
Okay, now we are going with bitwise OR. So bitwise OR, what will happen? Let us assume the same example. Okay, the example here we have, right? Same 6 and 3. Here also we have taken 6 and 3. Okay, so now we will convert first it to binary, respect like 3 to 0 0 1 and 6 to 0 1 1 0. Now we'll perform OR operation on bit level. So in OR, what happened? If any one is true, means true. If both are false, then only false, right? Okay. So just take this 0 and 1. So what result will get? We'll get 1. 1 and 1. If both are true, then true. 1 and 0. If any one is true, then also true. In only one condition it is false if both are false, right? Then whatever binary you will get, you just convert that binary into decimal, right? So when you convert 0 1 1 to decimal, you will get result 7. So if anyone asks you to perform bitwise operation or to perform bitwise OR operation, so you guys know that you can explain them exactly what is happening, why when we are doing A and B and A value is 6 and B value is 3, we are getting 7. That you can explain it, right? Okay. Now we are having bitwise XOR. Okay. So bitwise XOR, you always remember, if both are different, then you will get 1. Otherwise, you will get 0. So see, if 1, 1, true, true, 0. 1, 0, both are different, then you will get 1. In which bitwise XOR operator. Okay, bitwise XOR, remember. We also call it exclusive OR. When both are same, then 0. If both are different, then 1. Okay, now we'll take the same example. We'll see what will happen. So we have int a equal to 6, int b equal to 3. And when you have to write XOR, you have to use this symbol. Okay, so int result equal to a XOR b. Okay, so what I said, if both are different, then 1, otherwise 0. So first we have write here binary of 6 0 1 1 0, and then binary of 3, then binary of 3 0 0 1 1. Clear? So when you do, when both are different, then 1. If you see here, this both are different, then we are having 1. This both are same, so we are having 0. This also different, so we are having 1. If both are same, then we are having 0. So when you convert it, when you convert this, right, binary to decimal, you get 5. Okay. Now we have bitwise complement. We also call it bitwise NOT. So what it will do, it's pretty straightforward. It's turn all the bits to opposite, 1 to 0 and 0 to 1. So nothing else. You just have to take one variable. So I have taken int a equal to 6 and then result a equal to, here I have this bitwise NOT. So what it will do, binary representation, I will convert to their opposite number. So let us I have 0, so 1, I have 1 to 0, 1 to 0, 0 to 1. And whatever number we'll get, we'll convert that number to binary. So, and then if last number is 1, so we'll add minus. That's it. So basically, we perform second complement. Clear? Bitwise complement. Okay. Now we are having left shift operator. So we'll see this symbol. So how in program people used to write, and this left shift, right shift, they are very much used in data structure and problem solving. Okay, so we'll see some of the program later on how with bitwise or with the help of bitwise you can achieve less, like more efficient time complexity. Okay, so left shift operator. So shift all the bit of the number to the left by a specified number of position. So let's assume here it's saying int a equal to 6. Now it's saying a left shift by 1. So it means it's saying ki shift your bit by one position towards left. Okay, so we'll see what exactly is saying. Okay, so now we'll take this expression. Okay, so now we have 0 1 1 0. So when we shift by 1, so what happened? So we are shifting by 1. So now we are having here 0. And when you shift, when you're doing a left shift, right side you fill with 0. Whatever empty space will be there, you just fill with 0. So I have shifted one position, this one here, and this one to this. Okay, so now this become this already 0. From this position it's got shifted here, so this becomes 0. And now this one is also got shifted here because we are shifting by position 1. So now we have 1 1 0 0. So when we convert, 1100, it will become 12. Okay. Okay. But in like it's always pretty difficult, right? Let assume it's 6, so you did that. If it's 100, it's having 200, 300, so how you will do that, right? It's very difficult to do that. So we'll take one, two more example and then we'll see that. So there is a formula, okay? So number multiply to the power of shift. So let assume you have to do one shift. So here in the place of n, you will have that shift and the number in which you are performing shift operation. So usually what happen when in classes or in some interview, like people ask you, okay, can you write what will be the output? So you don't have to convert it to bit and then you shift your bit and then you will tell the answer. So it will take a lot of time for left shift, right shift and unsigned shift. So for them, we are having formula. We'll directly apply formula and we'll calculate and we'll tell them, okay, this is going to be result. Okay. So we'll see first here without formula how it's happening. So int equal to 5. What I'm saying is shift 2 bits. Okay. So first we'll take 8-bit representation of 5. So this is 8-bit representation of 5. Now what we are doing? We are shifting 2 bit. So basically, I see here in example, this one will go here, 2 bit, and this one will go here. And right side will fill with 0, 0. So if you see here, now in this place we are having 0. In this also 0 because shifted 2 bit. After 2 bit we are having 1. Then again this one got shifted to 2 position. So this one and the second position this one. So when you convert this, right, it will become 20. Okay. And then you perform just now. This is by doing bitwise manipulation. You converted this to decimal, you get 20. Now, if you go with the formula, what will happen? So now we have number is 5, and we are shifting 2 bit. So 5 multiply the power of shift, the 2. So 5 into 4 equal to 20. So best if you go with formula, so this is a formula for left shift. Okay. Okay. Now we have some certain points to remember. It shifts the bit to the left and add 0 in the least significant positions, the right side. Okay. The left shift by n position is equivalent to multiplying the number by 2 the power of n. So basically the second point is like this. So you take your number that is supposed to do with 5. So I have taken number, my number is 5. I multiplied 2 and power of n means shift. So if I shift 2, I do. If I have to shift 3 bits, I have to write 3. So 2, 4 and 4, 8. So 8 into 5, it will become 40. Okay. Okay, now take example of int a equal to 7. So now we know that it's happening on bit level, but we'll directly apply formula. So what we did, the 7 and we are shifting a by 1 bit, which result in 14. We'll see how it will result. So we have 7 number to the power of n, the shift, and then we'll get 14. Similarly, let's take example int a equal to 4. Okay. Int result equal to a and then shift 3. Okay. So now we have number 4 to the power of shift. So 8. So that is the reason we got here 32. Okay. So similarly here we are having int a equal to 10. Int result equal to a shift 4 position. We are asking whatever number you have, just shift it to 4 position. So basic, I'm directly going with the formula. So number to the power of shift equal to 160. Okay. So right shift we'll learn in next class. Okay, only 1 minute is remaining. So any question in left shift, bitwise complement and bitwise XOR and others like we have read. So anyone, like any question you have, you can ask, because we have remaining 1 minute left. You can utilize that. If any suggestion you are not understanding, that also. In next class, we'll finish off remaining right shift and unsigned right shift, and then we'll have some program related to bitwise operations. So you all understand, right?
So
Yes,
far,
sir.
So far clear, right? Okay. Okay. So fine, right? Okay. So we are learning about left shift. So left shift, I think yesterday we have completed left shift. Example also we're done with. Then we are going through right shift. Okay. So this left shift, right shift, and bitwise and bitwise OR. So mostly we'll use when we are having a certain complex logic and we try to achieve certain time complexity. In that scenario, it will help you. Okay, and when you are going for any product based company interview, right, their first round, which is a coding round. Okay, so when you go, there are many problems which we can shift on solve on bit levels. Okay, so that also will cover 1 2 program, not now, at the end when you guys are able to write a programs properly in Java. Okay, and we'll see, like usually left shift, right shift, when you are going with the enterprise application development, mostly will not encounter that, but in interview definitely you are going to encounter. And if you want to understand something in details, that is very much needed. Okay. Okay, so now I will just go through the right shift and then unsigned right shift. So basically, right shift, so its name only suggests. So we are shifting a bit towards right. Okay. So let's assume if they are asking you, okay, shift, do the right shift by 3 bit. So what you have to do, you have to let assume if you are having any decimal number. So you have first you have to convert that decimal into 32 bit of a memory representation. Okay, and then whatever binary representation that you have, just put everything over there, and then you just figure it out where is your on one, not zero, because you are shifting zero here and there, it will not make sense. So wherever you have one, right, you have to move that one from their exact position towards right by number of shift programmer ask, or if anyone asks you to do. So let us assume I have to shift by 2. So towards right, I will move that 1. And left side, what I will do, I will fill 0. Okay. Okay. So there are two things that we have to consider. What will happen if I am having a negative number? What will happen if I am having a positive number? Clear? So we'll see. We'll first go through these details. Okay. So it shift bit towards right by a specified number of position. Empty bits on the left are filled based on the sign bit. Okay, so what is the sign bit? Okay, so when you convert, right? So let's assume I have converted this. You see, 1 second. Yesterday also I have explained. So you have see this number 001. So even I can represent this one in 32 bit. What will happen? All remaining will be 00. That is the reason I have only taken this last 4 digits. Okay. Okay, so what is the last? Last is 0, means it's a positive number. Okay, so when you are with right shift maintain, if you are having a negative number and when you perform right shift, it will preserve your negative sign. Or if you have positive number, it will preserve your positive sign. Okay, okay. So if you go, empty bits on the left are filled based on the sign bit. If it's a negative, the leftmost will get filled by 1. If it is positive, then it will filled by leftmost bits, right, will get filled by 0. We'll see how it is. Okay, so now this is 0 1 1. So what I said, towards right we have to move, right? So if you see here, this one, right, I'm moving one place right and this one here. So what result I will get? 0 0 1 1. So what, it's a positive number, so you directly you convert this one, so when you convert you will get 3, right? And as I also yesterday class I've explained, when you are going with right shift, right, left shift, what you used to do, you used to multiply. You see this example, like that, this formula is supposed to, whatever number you have the power of 2 and the power of shift on 2, you are supposed to multiply with the number, but in right shift you're supposed to divide. So if anyone asks you, okay, what is the right shift, what is the right shift of 6 by one position, so you just take the number divided by 2 equal to, you will get 3. So even you go with the bitwise things, and either you go with the formula, so formula will help you to easily calculate the solution, and quickly you can execute the formula and you can directly tell that, okay, this is the way you supposed to do that, and you will quickly answer. Let us assume if I'm asking, okay, what will happen if I do 2 shift on number 8? So you can quickly say that, okay, 2 shift on number 8 to 8 divided by 2 and power 2, and then the shift is 2, so 2 power of 2, so the result will 4, so 8 divided by 4, then what result you will get, you will get 2. But if you are going on beat shifting and all, it will take time, right? So this is the formula for that. Okay. So now we'll take another example. Yesterday already we have visited this, but again we are just going through that. So we will get the idea before unsigned right shift. Okay. So int a equal to 8. Okay. Now we have result. So a shift by 1 bit. So towards right, I'm saying to first I'm converting this to binary. Anyone saying anything? No, right?
Oh, no.
Okay. So first I converted this to binary, and then I identify where is 1 and I shifted 1 by 1 bit, and I get this result, and then I converted this to decimal. Pretty straightforward. If you go by formula also, it's pretty straightforward. You have a number 8 to power of 1 because you want to shift by 1, then you divide 8 by 2, you will get 4. Same thing with 32. Okay. Okay. Now int equal to minus 32. So as I said, if you are having, first convert it. So when you convert it to binary, so you will get this. So this number, right, 1100. So you might thinking this is not the exactly binary of 32. Basically, for for 32, first you have to convert 32 to binary, and then you have to perform second complement. In I think narrowing I have already explained, right, how to do second complement. Invert all the bits and then add 1 to them. Okay, clear?
Okay.
So what, second complement representation, any time if you have minus, you simply convert this number to decimal, sorry, binary, and then do second complement. So after doing second complement you will get this. Okay, and then on top of that you have to perform right shift. So I'm just moving all the one towards right, and leftmost, as I said, if you have negative number, leftmost side will get filled by 1. If you are positive number, it will get filled by 0. And positive, there is no need to do second complement representation. Okay, clear till here? And when you convert this result, you will get minus 8. Okay, which is unsigned number. Okay, by formula, if you go, you will get the same result. You see, you just take minus 32 and 2 power of 2 equal to, and then minus 32 divided by 4 equal to minus 8. So clear? You guys have to know that basics, and you go through twice or thrice, you will understand all the thing. Even if you know formula, that is enough right now. Okay. Okay. Now we have a note. Already I explained that for positive number, all the leftmost filled with 0. For negative number, it will filled with 1. Okay. So let assume if you are shifting a digit, a binary number from right left to right. So their left position will get filled with 1 if that number is negative. Okay, clear here? Okay. Unsigned right shift. This is the last bitwise operator we are reading through, and then we'll done with the operators. Okay, we'll see the some example. So it shift bit to the right and fill the leftmost bit with zeros regardless of sign of the original. So unsigned bit, what happened, like in, if you see normal right shift, so what we are doing, if it's positive number we are filling with 0, if it's negative number we are filling with 1. But that is not the case with unsigned. Unsigned means it doesn't care about sign. Okay, it's negative or positive. So if you are negative number, it will also fill your left side with 0. If you are positive number, it will also fill the left side with 0. Okay. Only similarity is that it will also take second complement of your binary representation. That's it. While shifting, both use the same logic. Okay. So it's saying it shift the bit to the right and fill the leftmost bit with 0 regardless of sign of the original. So I have taken int a equal to minus 16, int b equal to 16. So int b is pretty straightforward. I don't have to say anything, just convert it to binary and shift, perform the shift that you want. If you want to do 1, you just move from left to right and that is done, nothing else. Similarly, how left shift is done, sorry, how right shift was doing, similar way it will do in similar fashion, no change. Okay, but for negative, it, for negative number it is not similar like the above right shift we have, that is unsigned right shift we can say. Okay, so we'll take this example and then we'll end with this. So first, because it's negative, okay, so we know that first we'll convert this to binary. Okay, so I converted this. I just converted this 16 to binary. Now I know that this is negative number, right? Okay, so what I said, if you are having negative number, you have to perform second complement. So first invert all the bits. So the reason is, in previous example you say I'm taking sometime 8 digit, sometime 4. The reason is all remaining will be 0, so no use of writing those, but it always have 32-bit representation. But here I intentionally put all this thing, the reason is it will all get converted to 1. Okay, so now the second complement I'm going to perform. The first step is invert all the bits. So I've inverted all the bits. See? So this is 1, it becomes 0, and other all are become 1, right? And then I have to add 1. So I'm adding 1. So if I add 1, so 1 1 0. Then again I have 1 1 1 0. Again I have 1 1 1 0. Again I have 1 0 1. Then here it's end with 0. Sorry, it's end with 1. Okay, so now we have 4 zeros and 1, and all remaining will be same. Okay, it will not get impacted. Clear? Till now it's clear, right? Okay, so now we have second complement representation of minus 16. Okay, so once we get second complement binary representation of minus 16, so now unsigned right shift of minus 16. Now we are doing unsigned right shift. So we'll shift by 2 bits. Okay. So normal shifting, move all the bits 2 place towards right and fill the leftmost with 0. But in signed one, we are filling with 1. But right now we'll fill with 0 because it doesn't care about sign. Okay. So what I did, these two I have moved here and this one here, right? If you see, and then other are 0. So if all move, so 2 to position will get moved and leftmost will get filled by 0 0. And then you have to convert this one to decimal. So, sorry, my screen is visual, right? I don't know what happened.
Yeah, it's visible.
Yeah, yeah. So when you convert it, okay, it will become this. Okay. So basically, when you perform on minus 16, when you perform unsigned right shift by 2, you will get this result. Clear? Clear, right? So you all got the clear idea about bitwise operator. In all the operator, if you go anywhere like any books and all, they have very less details about bitwise operator. So I try to cover as much as possible in bitwise operator, and it's enough for intermediate to advanced level, at least for operators. Okay, clear? So now we'll go with we'll perform certain program and then we'll done with operators. Okay, so my ID is visible, right?
Yes, yes.
Okay, okay, fine. Let me stop sharing this. Okay, so we'll just perform certain task and then one or two, and then basically we'll done with this. Okay, so let me comment this out. Okay, so we'll take example of one operator. Okay, okay, int a equal to, let assume I will take 17, or let take 6. Okay, and then I will have int result a and a is 6. Okay, so what I'm doing, I'm performing AND operation. Okay, you guys have to tell me, you can take a help of anything, first convert this to binary and then tell me the result. Okay, so what will be the result? So you can take help of Google to convert this binary and all, but you just mark it down, write it down and tell me the result. So anyhow, I don't care. Just only thing is that you guys are understanding or not exactly what this AND operator is doing. So what it will do? Okay, if you are not able to answer, just explain me what it will do. Basically here, what will happen here? It's a bitwise AND. So now,
The
yeah, so it's a bitwise AND. I have 6. So first 6 will get converted to binary. Then this 6 also get converted to binary. And then we'll perform on each bit AND operation. If both are 1, then only it will result in 1. If any one of 0, it will result in 0. Then whatever binary number we'll get will convert to decimal, and that is the result. Right? Right or not?
yes,
Yes.
Yes.
Okay. So, okay, let me see the result. So we got 6. You guys can verify that we'll get 6 or not. Okay. So you guys are doing something, or I will take the another example. So b equal to 3.
Yeah, one more example will be really helpful.
Okay. So int b equal to 3. Let's take int c. Okay. Int c equal to 4. Okay. And now int n result equal to, so I'm just performing AND operation, b and c. So what will be the result? You guys try. Okay. So if you have pen paper, you take a Google help and just ask Google, what is the binary representation of 3? What is the binary representation of 4? Okay. Then, as I suggested in my
I
video,
hope the I hope the result is 0.
The result is 0. Okay, we'll see. Okay. And anyone else? Any other guess? Hmm?
Takes
6. Okay.
no, I didn't say that. I thought it will take the value of B.
Value, it's not like it will take value of B. Okay. So let's assume I am having 3. Okay. And now what I am doing is first I have to convert this 3 into binary. So what will the binary of 3?
0, 1, 1.
0, 0, 1, 1.
Okay.
0, 0, 1, 1. Yeah.
Okay. Whatever it is, you just write it down in paper. Okay. First, and then what is the binary of 4? You write it down. Just how I was doing, right? How we perform addition of number, right? So first you write it down, then relative bits, right? Let assume if any bit on fourth position of uh for B, when you convert, okay, I will tell that. I will explain that one. Okay, don't worry. I will explain that. First, see the result. So result is 0. So who answered this one? I think uh
Manikandan.
Manikandan, right? So Manikandan, can you explain like how it becomes 0 so others will get help, right?
Yeah, sure. So for 3, the binary value will be 0, 0, 1, 1,
0 0
and
1 1.
1, 1.
Yes.
And for C, the binary result will be 0, 1, 0, 0,
0 1 0 0.
0, 0.
Yes.
So if you are doing AND operations,
Hmm.
so the same number, I mean the 1, 1, if you execute 1, 1 into AND operation, it will be result in 1. Otherwise, it will get 0, right?
Correct.
So
So the 0 0 will become 0. Then 0 1 will also become 0. 1 1 will become
1,
1,
0.
and 1
Yeah,
0 1 0 become 0. Right? Correct. 1 1. So
so
all
here there is no
here
values.
all will become 0. Right?
Yeah.
So basically, if all become 0, then result will be in 0. Clear? So it's pretty straightforward, right? Okay. Now we'll take another example. Okay. We'll take here int x. Okay. Int x is equal to 12. Okay. Int y equal to 10. Okay. Sorry. 10. Int z equal to x and y. So anyone, okay, I will do one more thing. Okay. Okay. So anyone else like can answer this. So what is the binary representation of 12? So it is like 1 1,
1, 1, 0, 0.
left 1 1 0
The
0.
answer is 8.
Okay, answer is 8. Correct. So you guys are able to understand that, right? 1 0 1 0. Now, so as I previous we did, right? So we'll see. So we'll see from the start 1 1, then it become 1, and all other are different. So 0 0 0. So
All are
what?
0.
So you will get 8. We'll see we are getting 8 or not. If you get odd, you will get 8, right? So clear here. So AND operator is clear. Now we'll go with OR. Okay. Let me take the example. So in the all this only will take is like why to write again, right? In similar. So here I was doing and, right now I will do or. Okay. So bitwise or, what will happen? So in bitwise or, if any one is true, then the result will be true.
True.
Right? So 3 or 4, B and C. So what will happen? 0, 0,
0, 1, 1, 1.
and then all are 1, 1, 1. So what will be the result?
7.
7. Correct. So you guys are able to understand that. So I will quickly move to another example. So we'll take a exclusive OR. Okay. XOR bitwise. Okay. Nothing. The same, we'll do the same. We'll take a example of the 6 and 3 itself. Only one example, and then we'll okay. So int num 1 equal to 6. Int num 2 equal to 3. Okay. So now what I want to perform? I want to perform XOR, which is called exclusive or bitwise operation. Okay. So here we have num equal, oh sorry, race equal to num bitwise num 2. Okay. So now for 6, what we'll get? We'll get 1 1 0, right? Okay. For 3 what we'll get? For 3 we'll get 0 1 1, right? So in exclusive OR, what will happen? If both are same, then it's become 0. If both are different, then it will become true. If 0 1, then it will result in 1. 1 0, it will result in 1. If both 1 1 0 0, always be 0. Okay.
0.
So here we'll see what result we'll get. So 1 0 is 1. Okay. Now we have 1 1. So both are same because it's exclusive or XOR. So both are same means it's 0. Right? Then again both are different, then it's 1. So when you convert this, you will get 5. The result will be 5. Okay, we'll see the result quickly. Okay. And then we'll run. Okay. So now we'll go to the left shift. Already we have done some example on left shift. So we'll, because in video I have explained with the example, the same example I will take. Okay. So left shift, one example I'm taking the example of 6 1. So let us assume int a, int x c equal to 6. Okay. Int result equal to xc, and then what I'm performing? I'm performing left shift. So left shift means the symbol will be like this. Okay, so how many bit I am shifting? In video I was explaining. First I have to shift a bit by 1. So I'm shifting bit by 1. Okay. So right now I cannot go to, if I ask what is the output, so you guys will go and convert to bits and all. It will take time, right? So I already told you, for this, for left shift there is a formula. What is the formula? So we take the number and multiply to the power of shift. So what will be the result here? So I have a number 6 which is getting multiplied by 2, which is have power of shift. So what is the shift here?
1.
1. So it's power of 2 which have power of 1. So what will be the result?
12.
What will be the result?
12.
12.
Okay, fine. So we'll see we are getting 12 or not, and then we'll take another example with the same formula. My intention is you guys should use formula properly. That's it. Okay. Other understanding is fine. You guys can again visit and understand that one. So you got 12. If I ask you to shift by 2, then what will be the, if you shift bit by 2, so what will be the result?
24.
24.
24. So you know how, so 2 to the power 4 and 6 multiply by 4. So we'll see what we are getting. 24. So you guys are able to guess it properly. Okay. Chalo. Then let us will make it a bit complex. Okay. So I am taking here 5 which have shift by 3. So what will be the output? Simple, use same formula na. So you have 5 multiply 2. So 2 have power of 3, right? So what will be the result?
40.
40. Simple. So whatever it is, you guys have to. Okay. Okay. So now we'll take another example. So we are done with left shift example already. Now we'll go with right shift. Okay. So in left shift we are doing multiplication. In right shift, what we supposed to do?
Divide.
Divide.
Division.
Divisions. Correct. So we'll take quickly zx equal to, we'll take example same 6. Okay. And then I have int rs equal to zx, and basically we are doing this right shift, right? Okay. So right shift by 1. So what will be the result? Let me print that rs. So
3.
what will be the result?
3.
3. Correct. How 3? So 6 divided by 2 which have power of shift 1. So 2 power of 1 become 2. Then we'll get result 3. Very good. Correct answer. You guys are able to understand. Fine. Okay. So now if I take here, let us take we'll take a complex one. I will take 32 here. Okay. 32 and 32 shift by 2. So what will be the result?
8.
8. So how it's become 8? So can any one of you?
32 divided by 2 to the power of shift, which is 2 to the power of 2.
Yes, correct.
So 32 divided by 4, it's 8.
Okay. Now last one. If I have here minus 32, then what will be the result? Straightforward. You can answer this one.
Minus 8.
So let it be minus. It is right shift, right? So even you are having minus, you will go with the same formula. Apply that same formula and tell me the answer.
Minus 4.
Minus
Minus 8 or minus 4. What you are saying?
Sorry,
minus
minus
8.
8.
Minus 8. Correct. Okay, we'll see that. Okay, so that you guys will get clear idea about right shift, and then directly we'll move to, because we have very less time, 1 minute left. So we'll directly move to unsigned right shift. I will take only one example of unsigned. Okay. Anyhow, in video already explained. So I have just, I will take it there itself. Otherwise, we'll run out with the time. So I have here 16. Okay. Okay. So now, as I have here 16 and minus 16 and then a shift by 2. So we'll see what output we'll get. Anyhow, if you calculate also, it will take, sorry. So unsigned right shift will have this symbol, okay? This 3 digit. Okay, let me check the output. So see the output. Already in my video, I have explained why we'll get that output. You have to follow that one. Okay. Clear? So we done with operators and mostly we'll get disconnected in